All right, this is Honors Algebra 2 Pre-Calculus. We're doing 5.3 in Pre-Calc, solving trigonometric equations. So sometimes we have an equation with mixed trig functions. When this happens, there are generally two options. Factor out a GCF, and if doing so means that each factor individually only has one trig function, you're all set. Or if there is no GCF, you likely need to use a Pythagorean identity to replace whatever function is squared. Once there's only one type of function, you'll be able to factor. So let's walk through these. All right, so first thing I should do is see if there's a GCF, and sure enough, there is. Now, remember, one side has to be 0 in order to factor, but obviously one side is already 0, so yay. So the GCF here is tangent x, and what's left when I factor it out is secant x minus 2. So either the tangent of x is 0, or secant x minus 2 is 0. Well, tangent is the y on the unit circle over the x on the unit circle, so if that's 0, it just means where is the y on the unit circle 0, which is here and here. Secant of x equals 2 is the same as saying 1 over the x on the unit circle is 2, meaning x on the unit circle is 1/2. Well, that happens here and here. So my answers are going to be that x equals, so this is 0 and pi, and then I don't include 2 pi, so 2 pi is not included, right? So we say that this is x is 0 or pi, and then this one is going to be pi over 3 and 5 pi over 3, right? Now, when I go to do b, there are two ways I can write it. I can either list all four of them, so 0 plus 2n pi, and pi plus 2n pi, and pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi, and that's fine, okay? Or I can recognize that this particular pair makes a straight line, right? They're half a circle away from each other. So I could write it as 0 plus n pi, which would cover both of these two, and then just write the other two, because the other two are not pi radians apart from each other, right? They're not a half circle away. So again, I don't care which way you write it. I just want to show you that those two options are the same, right? All right, moving on. Okay, so give this a try. It's the same basic idea. Already one side is 0, which is convenient, yay. I take out the GCF of sine of x, and I'm left with a 2 cosine of x plus root 3. So either sine x is 0, or 2 cosine x plus root 3 is 0, which would be cosine of x is a negative root 3 over 2. Well, sine of x is the y on the unit circle, so we want to know where the y is 0, and that's at the same spots we saw in the last problem. And cosine of x is the x on the unit circle, so I want to know where x is a negative root 3 over 2, and that's at the pi over 6's that are to the left of the y-axis. So my answer to A is going to be x equals 0, pi, 5 pi over 6, and 7 pi over 6. My answer to B could be written in two different ways. I could either write each one of those plus 2n pi, which is correct, right? There's nothing wrong with that. Or I could combine those first two because they are exactly pi radians apart, right? Those first two make a straight line, right? These guys right here make a straight line, right? These two. So the other way I could write this is I could write this as 0 plus n pi to cover those two, and then list the other two as they were. So 5 pi over 6 plus 2n pi, and 7 pi over 6 plus 2n pi. And I don't care which of those you pick. We're all good. All right. Now let's get a little bit trickier. I look at these, and these are not the same trig function. The problem is that there's no GCF, right? So if we, there's no GCF, right? And so while this is probably a secret quadratic trinomial, I can't factor it the way it's currently written. But what I can do is I can use a Pythagorean identity to replace the squared term. There is no way to replace sine. Like, I am stuck with this sign. It is linear. There is no formula for a linear sign that will replace it. But I can use a Pythagorean identity that says that this is 1 minus sine squared of x. Right? So there is a Pythagorean identity that says that cosine squared can be replaced with 1 minus sine squared. And now, what I should end up with is one of those, either a secret quadratic trinomial or something that I can just factor with a GCF. So if I clean this up a little bit, I have a negative sine squared x plus a sine x plus a 2. I don't like having a negative leading coefficient, so I'm either going to factor out the negative or I'm going to divide everything by the negative, whichever way you want to think about it. So when I factor this, right, I'm going to say, oh, let's call u sine of x, right? This is a negative 1 times u squared minus u minus 2, which is something you know how to factor. It should be a u minus 2 times a u plus 1. So either negative 1 equals 0, but that's a lie, right? Or u, which was sine of x minus 2 is 0, which would give me sine of x is 2. Well, that's also a lie, because if you picture a sine graph, right, sine graphs cap out at 1 and bottom out at negative 1, right? There's no time when sine is 2. 2's up here and sine doesn't equal 2, right? So that's also no solution. Or sine of x plus 1 is 0, which is going to give you that sine of x is a negative 1. That does happen. That happens right down here at 3 pi over 2. So it turns out that after all that work, my only answer is x is 3 pi over 2. And so my answer, if I didn't have an interval, would be 3 pi over 2 plus 2n pi for as many full circles as I want. So again, notice there's a lot that goes into that problem. I can't factor it with the cosine squared the way it is, right? I have to replace it with a 1 minus sine squared, and then I have to do a lot of work to clean it up. And then it turned out that 2 of these answers were also lies, right? Like negative 1 can't be 0, and sine x can't be 2. All right, let's try one more problem in this video. So same issue, right? You are stuck with this sign, right? You are stuck with this linear sign, but what you can replace is this cosine squared. All right, so that's going to be your job, is to replace that cosine squared. So I'm going to get that this is a 2. 1 minus sine squared x plus 3x. Oh, hey, this is supposed to say equal to 0, my bad. So oops. It's an equation. It should equal 0, my bad. That was a typo. All right, so plus 3 sine of x minus 3 is 0, right? So this is going to be a 2 minus 2 sine squared x plus 3 sine x minus 3 is 0. It's up to you. There's a bunch of different ways to deal with it. I either multiply by a negative or factor out a negative generally, so I get plus 3 sine of x. Let's see, this is a minus 5. No, sorry, it's a minus 1. This was a plus 2, my bad. Okay, so I'm going to either multiply by a negative or factor out a negative. It doesn't matter how you want to deal with it, but I'm going to get that this is 2 sine squared x minus 3 sine x plus 1 is 0, right? And I'm going to say, oh, my u is sine x, so this is 2u squared minus 3u plus 1. We can factor this into a 2u and a u, and they're both minus 1s. So either 2 sine of x minus 1 is 0, or sine of x minus 1 is 0. So sine of x is a 1/2, which would be the y on the unit circle is a 1/2. Or sine of x is a 1, which is when the y on the unit circle is a 1. That happens here and here, right? So my answers are going to be x is pi over 6, so this is A, pi over 6, 5 pi over 6, and pi over 2, right? That's my answer to A. And then for B, none of these make a straight line, right? So I'm going to have to list all 3 of them separately. There's no alternate options. So pi over 6 plus as many full circles as you want, 5 pi over 6 plus as many full circles as you want, and pi over 2 plus as many full circles as you want. And those are my answers. And I believe that that's it for this video.